All right, let's continue. Let's finish up the review of exponents. Here, what we're looking at are some properties of exponents you need to completely understand. So on question number 11, do you see that that's different from number 12? On number 11, the multiplication is in between those two. So think about that. So what you've really got is x squared, which is x times x, and x to the third, which is x times x times x, being multiplied together. So you can just see that there's 1, 2, 3, 4, 5 exponents. That should be x to the fifth. Don't just blindly memorize the properties of exponents here. If you do, you're going to mix them up. Just understand why that one is x to the fifth. Where number 12, 3, the exponent 3 is applied to the base x squared. So that means that you're going to take x squared times itself 3 times, which means you've got x times x being multiplied by itself 3 times, and that means you're going to have 1, 2, 3, 4, 5, 6 x's. All right, so yeah, the shortcut here is that you add exponents, and the shortcut for this case here, these two, you would multiply. But you can see why that's the case. And you got to really see and recognize the difference between those two. Notice that parenthesis is separating those two exponents. You got a power being raised to a power on number 12. Okay, where on number 11, you're just multiplying 2 powers. All right, so you may be multiplying the 2 exponential expressions, but the shortcut is you can add them. Okay. All right, now 13 kind of goes with question number 11 in a way. I could use a rule, but in reality, I'd almost like you thinking, well, x to the 7th means I've got 7 x's. I don't want you necessarily writing it, but I want you thinking it means you've got 7 x's multiplied together. Down here you have 3. So can't we knock out 3 of them? Because x over x would equal to 1. And so you see how I have 4 left. And the 4 left are in the numerator. So this turns out to be x to the 4th. All right, so really you don't want to just memorize rules. You want to kind of internalize the idea and make sure that you never mess that up. But there is a shortcut. Just like on number 11, when we're multiplying, the shortcut is we could add. When we're dividing, the shortcut is that we could take these exponents and just subtract them. All right, but I think it works better to think about it the way I showed you. Like, for instance, if x to the third had been on top, I don't want to have to go through, let me subtract, I'll get a -4, and then go through the process to finally get it written correctly. I'm just going to think about how there's 3 x's on top and 7 on the bottom, and so again, 3 of them are going to cancel out, and 4 are going to be left, but they're going to be left in the denominator. So that'll be 1. That would have been 1 over x to the 4th. All right, now here's the part that we're going to really be working on so that we'll be able to make use of the power rule when we're doing derivatives. So here's what you're being asked to do. So rewrite these expressions using exponents, so you get some number times some quantity raised to a power. Okay? All right, so looking at question number 14, when you see that square root, you know it's being something to the 1/2 power. And you notice how x minus 5 is completely underneath that radical. So that could be rewritten as x minus 5, but it would need to be in parentheses to the 1/2 power. Now, when you're looking at number 15, I want to try to write it so it's 5 times something, not 5 divided by x minus 2. So what I could do to make that happen is I could think of bringing that x minus 2 back up, but I would need to have a -1 on that so that these two would be equivalent. Think about how x minus 2 to the -1 would have meant 1 over x minus 2, and that would have been how that x minus 2 wound up in the denominator. So you're having to think backwards, how to take this and get it rewritten so it's some number times a quantity raised to a power. Okay? So on number 16, once you understand 15, number 16 is pretty straightforward. Wouldn't that be 5 times the quantity, x minus 2, and it would be raised to the negative 3 power. Okay? And then look at how number 17 has a denominator, and the denominator has a radical in it. So this is going to involve a fractional exponent, and the fractional exponent will need to be negative. Okay, there. So the idea would be that I could think about the x plus 3, the square root of x plus 3, as x plus 3 to the 1/2 power. Okay. And then I could get it back up with the 2 by remembering that if I had x plus 3 to the negative 1/2, then that would have caused me to write 1 over x plus 3 to the positive 1/2. So those should be equal. And now it's set up and ready so that I'll be able to go and use the power rule later. All right. Now on number 18, the 2 is not being raised to this 2 right here is not being raised to the 3rd power. That 3 is trying to indicate that it's a cube root. Okay? So on this one, I've got a lot of stuff going on. All right, so let's go ahead and kind of think through what this would look like. So I have a 1 over, there's still a 2 right here, okay? And then that cube root could be rewritten as a quantity, and that x plus 1 squared is all under that radical. So that's the base. So that right there, I could write it raised to the 1/3 power, okay? Everything underneath that fraction bar. All right, and then an x plus 1 to the 2nd power raised to the 1/3 power, that would be the same as x plus 1. These could get multiplied, so 2/3 power. Okay, and then it's still not quite the way I want it, because I want a number times an expression raised to a power. So what I want is to bring this part at least back up. So now when you're looking at that, I can think of that as 1/2 times 1 over x plus 1 to the 2/3 power. Okay, and that would equal 1/2 times x plus 1 to the negative 2/3. Oops, I don't need that parenthesis. Okay. All right, so you got to get to where you can do this. And, I'm stretching things out a little bit, but you actually get to where once you work with it quite a bit, you should be able to go right from there to there, okay? And on number 18, we wouldn't have to stretch it out quite so much. You'll get to where you can almost get right from here to the end. You really need to be working on that. It makes using that power rule, which is real, it comes up a lot. You have to be very good at it. Makes that so much easier, okay?